Okay, so I know it's been a while. I've had a lot of projects going on. I've got one that I just got done, another one that's close to done, and these guys here are part of the next one. I have no idea how long it's going to take, but I have a lot of these all-winner A10 ARM processors. And so I have a pretty major project I'm going to be doing with these guys. So that's going to take a while too. So I haven't had a chance to do a lot of video stuff and work on old computers and things like that. Well, this is actually all part of old computers, but anyway, yes, this is part of the project, but at the same time I haven't done anything that's really video worthy. So what I'm going to do today is one of my projects, not the one I just finished, but one that I'm going to be finishing up soon, is going to be using shift registers. So I thought this would be a good chance to maybe do a little bit of a learning exercise for anyone who might not know about shift registers, how they work or how to use them, what you can do with them. So I'm going to go ahead and talk about shift registers in this video. Probably won't be too long of a video, but I thought it was interesting, and I thought maybe some people would be interested, so here we go. So the shift register that I'm going to be working with here is the 74HC595, and this is a serial in shift register. So it gets one bit at a time. So what it does is it'll take one bit, 0 or 1, and it'll put it in the register. It'll shift it to the register, and then it'll just keep shifting all the bits that you send it serially, and then when it gets to the when you pulse the clock for the shift clock, what it will do is it will move all of the bits into the latch. This is the shift clock. And this is the latch clock. So what it does is basically, so say you want to move 8 bits into the shift register. So you can say you just have 0, 1, 0, 1, no, 1, 2, 3, 4. So you say you have this byte right here. So it would shift 1, 1, 1, 1, 0, 1, 0 into the latch, and then when you put a voltage to the latch clock, or you make it high, it will move those in parallel. So to move all those bits out all at once in parallel. With this shift register, it also has a serial out as well. You can do them out serially, but we're not going to use that. We're going to use parallel out, so we're not going to worry about that. So that's how this will work. So this is our serial in, our serial in. So basically our microcontroller we'll send a series of bits, and once they're sent through there, we will send the shift clock to high, and then when we're ready to release them out, we will move the latch clock to high, because these can keep shifting, so it can keep sending. You can keep sending these the whole time, but once the bits are latched, it's not gonna allow anything else until these are moved out. And the EO is just enable. That's going to open that is going to basically release the bits out from where they're latched inside. So basically this is active low, so this has to be low before before basically this will work. So what we will do is just keep this low all the time, because really the latch clock is what we'll be using to release the bits out in parallel. So that's it. So we have our VCCC here, which is 5 volts, ground here, and we have our bits basically. So we have QA, B, C, D, E, F, G, and H. So these will be all the bits that will be going out in parallel. So if it were serial, they would go, 0, 1, 0, 1, 1, 1, one at a time. But since it's parallel, they're all going to go out at once. And we're going to see how that works by doing a little bit of coding on a breadboard here. These LEDs will represent our 8 bits. Move this way. These LEDs will represent our 8 bits, and we have our 74HC595 here hooked up to the Arduino. And I'll just tell you now. Well, we'll look at the code later, but basically I already have all this stuff hooked up. I have, well, I don't have these connected yet. I have to go back and look at where I connected them. Or actually, I can just look here on the page. So let's see here. We have, that's the top. So we have Q, so pin 15, which is right here. It's going to be our first bit. So we're just going to connect that to this LED. And so the rest of them are just 1, 2, 3, 4, 5, 6, 7. So that's pretty easy to remember. So we're just going to move these to two. 3. 4. 5. 6. No, 6. Wait, you better suck. 6. 7. What's wrong? What happened there? Oh, sorry. Yeah. 7. And then 8. So like I said, each one of these is going to be 1 bit. So this is basically a byte. So each one of these is either going to be on or off. That means it's going to be either a 1 or a 0. So this is our first bit here, and depending on whether we make it go from most significant bit to least significant bit, this will either be the ones place or the 128 place. So it would start with 1s, 2s, 4s, 8s, 16, 32, 64, 128. So we could actually use this to count. So, this would be like, basically adding, because, binary is just basically, we can count to 255 with 8 bits in binary. So if we start with 0, it's actually 256 digits, but we start with 0. So say the first LED was on that would just, and none of the other ones are on, that would just be 1. If the second LED was on and none of the other ones on that were on, that would be 2. If the third one was on and no other one was on, that would be 4. And if the third and the second were on together, we'd have 4 plus 2, that would be 6. Say the first and the second were on, both on, and none of the others were on, that would be 3, because we'd have 1 and 2, that equals 3. If we had just the third place and the first place on, well, we have 4 and 1, that would be 5. So it's just 1, 0, 1 is 5. So we could count to 255 with this, and we will do that, or we'll do some things like that. So let's go ahead and get on the computer and look at some code, and then we'll try it out on this. I'm not sure where this is supposed to go. I think this is just, this is supposed to go here for the, it's supposed to go here for the rail. I'm not sure about this one though. I had this set up a little bit differently before, so I don't really need the positive rail on this side, I don't believe. I shouldn't anyway. So that's that. Let's get on the computer. Before I go on, I forgot to mention a few things. This here, pin 10, is the clear pin. What this will do is clear out all the bits in the latch, and don't really need to use that very often, but we will use it in the beginning, because sometimes when you turn on a circuit, sometimes random pins will have random voltages. Sometimes they'll be 0, sometimes they'll have 5. You just never know. So it's best to just clear it from the get-go, and then we'll leave it at that. That's all I wanted to mention. Also, I wanted to say, I didn't really say much about why you might want to use this. Well, one really good reason to use this is to save pins from your microcontroller. So instead of sending out, using one pin from your microcontroller for each one of these bits, you can just use one pin and send all the information, all the bits into this IC here, and then move it to where you want. So it can save you. That is probably one of the main purposes for using one of these. That's what I've been using it for in my project, is to save pins. So what this does is just, like I said, takes your serial bits, moves them all into one chip, and then pushes them out. Saves you 8 pins on your microcontroller, each one of these would. So that's how that works. And if you're doing something with larger than, say, 8 bits, you could use 2 shift registers and add them together. There's nothing stopping you from doing that. But I just wanted to mention that. So let's get on with the code. Okay, so here we are in our Arduino code, and as you can see here we have 74HC595, that's what we're using. So I decided to use pin 10 for our serial in, and for our shift clock I'm using pin 9, and for the latch clock I'm using 8, and for clear I'm using 7. We're going to make them all output when we start the program, and then I'm going to do bring the clear pin low, because it's active low. So what that will do is clear all the bits out of the IC, and then we'll bring it back to high so that it will basically turns the clear off, and we will keep it high. So here, I'm going to get rid of this real quick. I'm going to just comment it out. So say we have a byte here, and we're doing this byte in binary, which we would do by 0B, that represents binary. And like I had it on here before, let's say we want every other light to be on in the LED, or whatever code. Maybe we're doing something different, but in our case we're using LEDs. So let's say I want every other LED on. I would go 1 0 1 0 1 0 1 0. that will have every other LED on. So that's our bytes right here. That's what we're going to send to the shift register. So what we're going to do is we're going to bring the latch clock low, and that opens it up, or allows the bits to be put in. And there's an Arduino function, shift out, and what we're doing is we're using serial in, that's our serial input, to move these bits into the shift, by using the shift clock pulse. And we're doing most significant bit first, which would be 128. If we do LSB, it would be 1, the ones place, and then I, and that's, we're not going to use I. We are going to use the bits, the bytes. Okay, and then we bring our latch clock high, and what that will do is basically move all of the bits out into our LEDs. And it's just going to keep doing this over and over because I have it in the loop. So it's going to keep sending 10, 10, 10, 10 over and over again to the LEDs, basically. So let's have a look at that. Okay, so we will just upload our sketch now, which won't take very long at all. Okay, and as you can see, every other LED is lit. Okay, so having done that, let's just say we want all of them to be on. We would just go 1, 1, 1, 1, 1, 1, 1, 1. So now all of the LEDs will be lit. And as you can see, all of the LEDs are now lit. And so as you can see, we can do this with binary, but we can also do it with hex or decimal numbers. So this binary number here is 255. So we could type in 255 here, or we could do FF, which is 255 in hex. So if we do the same thing, all of the LEDs are lit, as you can see. Or we can do 255. And to the, to the compiler, it doesn't make any difference. It sees it all the same. So it sees 255 as 1, 1, 0, 1, 0, 1, 0, 1, 0, or 1, 1, 1, 1, 1, 1, 1. So that doesn't make any difference. So that being done, let's use it to count then. So we can just get rid of this. I'm just gonna comment that out there, uncomment this, do our for loop here, and we'll just use I. So what this will do is it will count, and it will count in binary. So basically it's going to count from 1 to 2. Each light will come on to represent whatever number it's on. And I will show you that. I'm going to, it's a little slow, or fast, so a little slow, I mean. Let's make it 350 to make it not too slow, but not too fast. We'll go ahead and upload that. And as you can see, it's counting. What it's doing is going from 1, 2, 3, 1, 2, 4, and when it gets to the number that each LED represents, it will stay lit. So right now we're at, well, it's hard to tell. See, now we're at 64. And then once it gets to 128, the 128 will be lit, and then it will start back over to get to 64. It's almost there. Now we're at 128. It's hard to guess. It's hard to count each. It's hard to count in decimal through binary that's quick. But 120, it'll be 128 plus 64 in a second. Okay, now we're at, well, 128 plus 64 is 128 plus 64 is 172. I don't know. I don't remember. I don't want to do math. 128 plus 64, no, 182. 192. I don't know. And when it's done, it just starts back over from 0. And it'll do it again. And that's it. That's the shift registers. They're very useful. They come in handy, especially if you have a small microcontroller with not a lot of outputs. You only need 3. You can get 8 outputs with just 3. If you're outputting binary, it actually doesn't matter if it's binary or not. I mean, if it's just high or low. So if you need to output of voltages to some things and they're 5 volts, and you're using an Arduino or an AVR or anything like that, then you can certainly use a shift register for such things. Anyway, so I hope you enjoyed this video and got something out of it, and please like and subscribe if you haven't already. I would really appreciate it, and I will see you next time. Thanks a lot for watching. Take care. Bye.